Hello, my name is Edson Gomez, and I'm going to be showing you how I built my force measure and how it works. First, the materials you're going to be using are a PVC pipe, a wooden cylinder that fits inside the PVC pipe, 2 hooks for each end of the wood, a 63.5mm spring, 1 big and 1 small S hook, some string, and finally a plastic cup. To begin, you are going to want to get each hook and screw it into each end of the wooden cylinder. Next, you're going to want to attach your spring to one end. Next, you drill a hole into the top side of the PVC pipe that goes fully through. Once you do that, you get the big S hook and feed it through the holes of the pipe while the wood is inside in order to grab the spring. Next, you attach one small S hook at the bottom of the wood. Next, you get a plastic cup and drill through it and put string through it and tie it up. Once you do that, you are able to hang up the cup on the small S hook and your force measure is finished. In order for the force measure to work, you have to hang it up and you're ready to start. Now, since the cup is a part of the beginning ground mark, we have to know how much it weighs in order so that in the future we take into account our estimates while filling up the cup with mass. We see here that it weighs 9 grams. You leave it hanging and leave a mark by where the stick touches the pipe in order to know where the beginning force is, which is 0 newtons. Now, for me, an easy way to fill up the cup fast with mass is by using coins. You're going to want to fill it up until the cup is 109 grams. The reason you do 109 grams and do not do 100 is because the cup weighs 9 grams and you're going to have to take into account the cup while weighing it to leave your mark. You do the same as you did before in the cup without anything in it and leave a mark on the wood in order to see where the next force is, which is 1 Newton. Next, you do the exact same thing, but this time with 209 grams. You do the same thing as you did before with the 109 grams, and you see where the next force is, which is 2 newtons. Again, you do it again with 309 grams, and leave your mark in order to see where the next force is, which is 3 newtons. Now, once you do that, your force measures should look somewhat like this with a whole bunch of marks on the wood that determine where the forces begins with the newtons. Next, you're going to want to use various objects that you do not know the mass of. For instance, I used a deodorant stick. I also used a small little Polaroid camera. And finally, I used a little bottle. You want to put these objects inside the cup in order to test it out. Now, to be able to determine how much each object weighs, you have to do the exact same thing that you did with the coins in order to see where it lies in between each force. For instance, the Old Spice bottle I estimated was 81 newtons when using the force meter was 85. The Polaroid estimation was 64 newtons, while the measured weight from the force meter was 60. And finally, the water bottle ended up estimation was 287 newtons, while in the force measure it was 270 newtons. Now, the original spring size was 63.5 millimeters. Once you do the first experiment, you're going to want to do it again, but you're going to be able to see a difference between each object landed in the force meter. For instance, the deodorant bar actually ended up near 180 newtons. The Polaroid camera ended up falling near 160 newtons, and the water bottle ended up falling in between 270 and 280 newtons. In order to estimate what the maximum mass is for my force measure, I decided to continue with the experiment and decided to add 100 grams each time into the cup in order to see where it would lie in the force measure. I then started adding various objects into the cup in order to get 400 grams, or roughly around 400 grams. I did this in order to see where it would lie in the force measure and how much farther it would go because of the spring extension. I then used a hand sanitizer bottle and filled it up until it was around 500 grams in order to see where 500 grams would lie in the new force measure because of the spring extension. Around 500 grams was where the maximum mass was. I knew this because the stick had gone all the way down through the PVC pipe and there was no more stick left in order to determine how much force was. That ended up being around 9 newtons. Before we did any experiments, the original spring size was 63.5 millimeters. At the end of all experiments, the spring size ended up finishing at 203.2 millimeters. It grew so much because of the spring tension that was happening with all the force being applied to it, and it ended up stretching out. Now, in order to determine how much mass each and original object had, we had to use the formula F equals mg. The original force for the deodorant bottle was 85 newtons. The new length was 20 centimeters from the bottom, while the original length was 16 centimeters from the bottom. We are able to see that the extension was 4 cm. I used the 4 centimeters as the part of the acceleration for my formula. So I then did 85 divided by 4 in order to get my mass. But since it was in kg, the mass of the deodorant bottle ended up being 0.021. The Polaroid camera force was 60 newtons. The new length was 19 centimeters from the bottom, while the original length was 14.5 centimeters from the bottom. The extension had been 4.5 centimeters. Now, I used 4.5 centimeters as part of my acceleration and divided 4.5 into 60 newtons in order to get 13. But since it's in kg, the total mass in kg was 0.013 kg for the Polaroid camera. The final object was the water bottle. The force on it was 270 newtons. The new length was 28.5 centimeters from the bottom, while the original length was 23.5 centimeters from the bottom. The extension was 5 centimeters. I used 5 centimeters as part of my acceleration for the formula. I divided 5 into 270 and got 54. But since the mass is in kg, the total mass in kg was 0.54 kg. For question 1, I would say that the spacing in the scale is pretty different. Once the spring gets more stretched out, the more higher newtons it has, since the string is getting weaker and the more force that is being applied. This makes it an ideal force meter because we are able to see that since there's more mass being applied to it and since the spring is getting weaker, the more force is being added. For question 2, in order to make a force meter to measure greater forces, you would add more length to the PVC pipe and the wooden stick and add a more stronger spring. You do this so that you're able to do a lot more mass and determine more force on it. In order to make a force meter for lighter forces, you do the opposite. You would make everything a lot more smaller in order to see the grand difference within smaller scales of mass. I would say that a limitation in my design is the amount of space that I have. For instance, if I were to want to make a force meter that is that can have greater forces, I would want to make it more bigger. But since I do not have enough space for that, I would be unable to do that. Another limitation that I would say that my force measure has is that it is able to break very easily because of the spring. Now, if you were to want to get more springs in order to test it out, that would also be fine, but it would be better to find a better solution that where you do not have to buy springs in order to use it again. Some problems that I had while building my force meter was not being able to find certain materials. So what I did was use YouTube and use other sources in order to see what I can use in order to replace those certain materials. The force and the extension of a spring is related because the more force that is being applied to it, the more stretched out the spring gets. And over time, once you keep adding more and more force, the spring will get much more heavier and lose a lot more tension, which means that it will drop a lot more. When you double the force, the extension actually doubles itself as well. Since the force is being doubled, which means for number 6, when you double the force, the extension also gets doubled. This happens because the more force that is being applied, the more extension will also happen. And finally, for number 7, I found the second method a lot more easier since I'm used to using the formula, and it was more easier for me to determine the differences of each length in order to decide what the mass was. This is all, and thank you for hearing my project.